Yeah, in this tutorial, we are going to cover some further functions used in the NumPy on the regular basis. We'll start with the generation of random numbers. Let's say we want to create an array of random numbers. So what we use is np.random.random is a function, okay, and then we have to specify the size. Let's say we specify the size as 3, 2. Then it creates a two-dimensional array with 3 rows and 2 columns, and these are the random values that get populated. We can also generate a random array where we can specify the range, that is the low and the high value, and then we can also specify the size of the array. So let's say we want to create an array of size 3 by 3, such that the values that get generated randomly should have a low value of 2 and the highest value of 10. Then we can say np.random.randint. So randint means it will generate integers instead of float like we saw in the previous example. So it will generate array of this size 3 by 3, and the lowest or the minimum value will be 2 and the highest value will be 10, and randomly these elements get generated. So these are the things which we use. Let's say we want to do some operations on an array and we want to create array in a quick time, then we can use this random methods to generate those arrays and we can perform operations on them. Another operation that we commonly do in the NumPy is to change the shape of the arrays. Let's say we have an array ARR which is of size 3 by 1 2 3 4 5 1 2 3 3 by 4, okay. So that is, there are 12 elements in it, so 3 rows and 4 columns, so 12 elements. Now we can change the shape of it. We can say ARR dot reshape it will, and the new shape, so it is 2 comma 6. So earlier there were, we saw that the shape was 3 comma 4, that is 12 elements in it. Now the new shape that we specify, it should be such that the multiples of row and column should match with the number of elements in it, otherwise it will give an error. Since there are 12 elements, you can give like 2 comma 6, so this will create 2 rows and 6 columns. So that is the reshape method. One thing to note with the reshape is it actually creates a new array. It returns a new array, it doesn't change the original array. Okay. Another way to change the shape is you can specify the transpose function. Transpose converts rows into columns and columns into rows. So we have 348 as this. So 348 gets transposed like this: 4679, 4679, 572 column, 575 as a row, 624 as a column, 624 as a row. So this is actually the transpose that we use in matrix operations normally. Yeah. Next is to flatten the array. So we can use arr.ravel function. It just simply flattens the array into a single array. So the two-dimensional array gets flattened into a single dimensional array with all the elements in it: 3 4 5 6 4 6 5 2, 3 4 5 6 4 6 5 4 6 7 2, and then 8 9 5 4 8 9 5 4. So these are the methods to change the shape of an array. The thing is, they return a new array, they don't change the original array. Now if you want to modify, if you want to do the modifications within the original array itself, then you can use the resize function. Let's say we give arr.resize 6 comma 2, so it will make the modifications on the original array arr itself. So arr.resize 6 comma 2 generates modification in the original array arr, and then when we print arr, then we see, okay, it has a 6 rows and 2 columns. So this way we can change the shape of the arrays. Now next is the stack of the array. So let's say we want to combine two arrays. Then we can use the stack operation. One is the vertical stacking and other is the horizontal stacking. So vertical stacking is like, let's say we have this is one array and on top of it there is another array. So this is array A and this is array B, and then we create array one on top of the other. This is the vertical stacking. Okay. So how do we do it? We have array A. Okay, we generated using this randint random method that we learned earlier, and the array B. Okay, the array A has 1 2 3 4 columns and 1 2 3 rows, so 3 by 4, and array B is 2 by 4. We just want to create a vertical stack, that is this array should get vertically stacked below this array. Okay, so what we have to do is we just call the function np dot v stack, and then we specify the two arrays which we want to stack vertically, a comma b. So at the top we see array A, which is 846, like up to here this is array A, and below this we get array B. So in this way we get as an output a single array, which is basically a stack, vertical stack of these two arrays. Another is the horizontal stack. Horizontal stack means we are stacking arrays side by side. So if I go here, what it means, like we have array 1, and then in the horizontal stack the another array gets added horizontally. So this is array 1 and this is array 2. So this is the horizontal stacking. Yeah. So let's see. We have array A. It is 2 rows and 3 columns. Array B, which is 2 rows and 2 columns. And we want to horizontally stack. That is, we want this 11, 12, 13, 14 to just come next to array A. So what we do, np.hstack and a comma b. So 2, 3, 4 and 4, 5, 6 up to this portion that we get is from array A, and then horizontally it gets another array which is B stacked to it. Okay, so that way we can create the horizontal stack. We can also combine 2D arrays and 1D array. Let's say we have array A, which is having 3 rows and 2 columns. Let's say these values are present in array A, and we have array B, which is just a single dimension array. MST are its value. Now we want in the output we want let's say these represent something like height and weight, and we want these labels MST, let's say medium, small, and tall, to come next to it. So for example, 140 40 should be like medium, 120 20 should be small, and 150 50 should be tall. So what we do is we just simply use a dot t, which is like transposing the array A. So it transpose it into rows get transposed into columns and vice versa. That is, a dot t will generate 140 20 50. A column gets transposed into rows as 140 120 150. 40 20 50, which is a column, gets transposed into rows as 40 20 50. Now this is the row, and we just simply now stack mst just below it here using the vertical stacking. So we say np dot vertical stacking a dot transpose, which is this, and then the b is mst, and the final output whatever we get, we again want to transpose it so that we can get vertically everything the way we want it. So np dot v stack, uh, whatever output we were getting, we just simply transposing it. Now this is what we got as what we wanted: 140 40m, 120 20s, and 50 50st. Yeah. So in this way we can just add the two-dimensional and the one-dimensional array. There is another term which is a new axis. So basically it's a pseudo index that allows the temporary addition of the axis. So it simply adds a dimension in the array. So what we have to do, let's import it from numpy import new axis. Let's say we have array A with 3 elements 1 2 3, and array B with 3 elements 4 5 6. Okay. Now if we want to horizontally stack, that is, we want 1 2 3 and then 4 5 6 like horizontally stack on top of each other. And if we run just run np.h stack, it will not generate the horizontal stack. It will just simply append everything into a single array. So how do we achieve that horizontal stacking? So one way is, let's say, let's check the shape of the array is 3, and what we do is we are saying a new axis comma colon. So simply it will add an axis here because we are specifying new axis here. So it will add 1 in place of new axis, and then it will generate the element. So this a gets transformed into 1 2 3, and if we check the shape of this, it becomes 1 comma 3. That is, we specified new axis here, so this will become 1. So this axis is 1, and the 3 is the number of elements which get shifted. Now on the other hand, if we say a colon comma new axis, then it means we are specifying new axis here. It means 1 gets added here, so one dimension gets added on the second axis. So if we take the shape of this, we will get 3 comma 1. So 3 and 1 gets added in as the second axis. So these are the vertical columns. Now our task was to just simply append A and B either horizontally or vertically. So what we can do is we can do A colon new axis and B colon new axis, and we just do horizontal stacking. So it will generate like this 1 4 2 5 3 6. And if we just simply transform whatever the output we are getting, then we can get 1 2 3 4 5 6. This is what we wanted initially, that is to do the horizontal stacking on top of each other, that is 1 2 3 and 4 5 6. This is how we achieve this. Another important thing which is very useful is to understand the difference between the assignment copy and copy that is a shallow copy and the deep copy. Now, if we do the simple assignment, just say, let's say we array A and it is having some elements in it, okay, 10 elements in it. And if we simply assign array A to B, then B actually you can understand it like it's like a pointer, or it's something which is like referencing A. It's not like another new object got created. For example, if you see the ID of B and ID of A, it is true. It means B is nothing but it is something which is pointing to A itself because their IDs are matching. What it means, if you make any changes in B or in A, the changes will be reflected. Let's say if you array A, you assign it to B, and believing that believing that we make some changes in B, then what we should be careful is whatever changes we make in B, that will also get reflected in A. So we have to be very careful when we are doing just a simple assignment. For example, in case of here, we just change the value of zeroth element of B to 100, we see okay, B got changed, that is fine, we did it. But if we check array A, that also got changed, which sometimes you don't want it because you want original early to remain as it is, and any modifications you do in the assignment array, let us B, it should not get reflected in the original one. So this will not work in those cases, okay. And at the same time, if you change the size of the, just that is, if you change the shape of it, let's say you change it to 5 comma 2, so B will get changed, yes, but at the same time A will also get changed because B is nothing but something which is referencing A. So whatever changes you make in B will get reflected in A. So just simple assignment, be very careful. If you're assigning an array to another variable, then whatever changes you're making in that new variable will get reflected in the original array, which is something which is not desirable in most of the situations. Yeah. Now let's say another thing that we just want to highlight here is that whenever we call a function and we pass an object, a mutable object to it, then it basically gets passed as a reference. What it means that any changes you make to that particular object in the function, it will get reflected in the original object, which also we probably don't want in most of the situations. So what I've done here is we've just taken a function f and we're passing x as an object and we're printing the ID. So let's say we have an object A, its ID is this, and if we pass it, call the function A and pass A in it, and within the function we're printing the ID, we found that okay, it's the same ID. So it means it's actually pointing to the original object. So any changes you make here in the function of corresponding to x will get reflected in the array. Another thing is the understanding the difference between the shallow copy and a view. So basically, shallow copy is something that points to the underlying same data. However, the structure can differ. It is also called as the view. So let's say we have array A and it is like this, and then we create C, which is basically a view of A. So C equals to A dot view. Now if you see ID of C and ID of A is not equal, it means C and A are not equal. C is a different object altogether. Fine. Now this is C. Now we change C. So we change one element, that is 00, that is this element, change it to 500. So C got changed. Okay. Now if we change A, if we see A, we found that A also got changed. Okay. Even though it's a view, it's but still uh, uh, any changes to the C are making changes in the original array A. So in the shallow copy, the changes get reflected into the original array. What doesn't change is the shape. Let's say uh, we change the shape of C to 5 comma 2. So C got changed, that is fine, but the structure of A didn't change. So what it means in the shallow copy, the underlying data is the same between these two arrays. However, but the size, okay, the size or the shape that gets changed. So it's like we are creating a different view, but the underlying data is same. Another thing is we can create a shallow or the view by uh, using the slicing method. Okay, let's say again we have array A and we create C, which is A, then bracket start colon comma colon. So this is like a slicing. So this also creates this is another way to create a shallow copy. So that is whatever changes you make in C will get reflected in A in terms of the data, but the size, that is the shape of C and A can differ. So this again is something which probably we do not want. That is, whenever we copy an array, we want original array to remain intact, and whatever changes we do in the new array should not get reflected or should not get passed in the original array, because then it will create some problem. So to avoid these things, what we need is the deep copy. So how do we create a deep copy? We just simply say, let's say we have array A and we want to create a deep copy of it, that is B equals to A dot copy. So what it means, any changes we are making in A will not get passed to B and vice versa. That is, any changes we are making in B will not get passed to A. So they are basically totally different objects in terms of their existence and in terms of their data. So ID of A obviously is not equal to ID of B, and if we make any changes in B, it will remain with B only, and these changes do not get reflected to the original array A. And if we change the size of the array B, the size also does not changes in the array A. So this is a very important difference to understand between the deep copy, shallow copy, and the simple assignment. If you just simply assign a array to another array and you perform the operations, so be very careful whatever changes you do in the assigned array will get reflected in the original array. So in those, to avoid those situations, such situations, we can uh, use the deep copy method, so that whatever operations we do in the new array should not get reflected in the original array. I think that's it for now. Thank you.